Okay, right. So there we can see that the auger in earth for 480 millimeter diameter pile not exceeding 10 meters, right? And it is because we have my pile at 6 meters for type A. We have 12 of those. We've ascertained that the 12 there is in fact that the 12 there is in fact the 12, the four piles sets multiplied by 3 piles per set. And the 6 meter is times 4. It will be the 2 piles multiplied by the 2 pile sets. So that is how we will be going about with the auger of that. Then also tells me extra over augering for the 480 millimeter diameter pile for the under reaming for the enlarged foot, and the diameter given to us is 1080, which we pick up off our drawing, and it says on type Y base is applicable to all the piles, and the diameter is 1080. Again, it's measured in number, and we indicate that there are 12 for type A and 4 for type B. Extra over augering and under reaming in earth for augering and under reaming in soft rock, because we need to and remember that the specification said that we had to allow for 10% for soft rock and 5% for hard rock excavation. Is it our concern how the contractor will do that? It is not our concern. The contractor will allow, and hence we are measuring that as extra over augering and under reaming in earth for augering and under reaming in soft rock. That's times 10%. Whatever the volume is will be times 10%, and ditto, but in hard rock is times 5%. So whatever it is there is times 5%, because it's 5% that we need to allow for that. And then also extra over augering for carting away the surplus material from the pile holes to a dumping site. And there we can still indicate, we did not indicate the distance there or selected by the contractor, but when you do get given the distance or that the contractor should allow for that him or herself, it's important that we include that in this description here, maybe say to a site
selected by
the contractor. Because we are not sure of what that is. It could have also said the following:
plus minus 10
to a site
5 kilometers
away. You could have said that too. So, but we need to. It's important that we allow for the extra over for the removal, because the same volume that we have there now would be carted away. Because we will not be using that. We will not be using that for as backfill. And what do my dimensions be? 0.24. That will be the 480 divided by 2, and my radius is then 0.24. Multiply 0.24. Multiply by the height, which we're given as 6 meters, times pi times 16. And then why 16? Because all 16 of these piles are the same diameter and they are the same length. The 12 of type A and the 6 on the 4 of type B. They are all, that is why it is times 16. Then I asked a question 2 weeks ago. Which one do you prefer? The one that shows that there is the one where you have that divided as a cylinder and then as a partial pyramid, a partial pyramid where we use the Prismoidal formula. And I was said, and I'm trying to think who said that, but I will remember in time who said that. They said no, we prefer the method that is shown here, whereby it is given to us that it is the 0.3. Where do we get 0.3 from? Can you tell me where we get 0.3 from?
It's the formula.
Anybody of you remember where we get that from?
I think so. You use the formula for the centroids for a right angle triangle. I'm not sure if are you not referring to that.
Okay, I'm gonna again try and show where we get the 0.3 from. But if you take 1080, 1080 is what? It is the diameter of the under rim section, right? So you deduct, you say 1080. I'm gonna
Divided by
this
2.
It says 1080,
540.
which is the diameter, minus the diameter of 480. 480 is the diameter of the pile. And if you take that, you say 1080 minus 480, that gives you 600. Gives me 600 millimeters. Right? You then divide that by 2. By 2, and that will then give you
300
millimeters. So the part on the outside, and this is where I need to make a little drawing. I'm trying to think what I used to make my sketch last time around. So I'm just trying to see. Trying to insert a shape, and the shape that I want to insert is a basic shape. Okay, now that is the shape on the one side of my under rim section of my pile, with the height from there to there being 500. All agree with that? That the height is 500 from there to there. I will just jump out of this quickly to show exactly where it is I am referring to. Can you see my drawing?
Yes. Yes, sir.
Okay. Now the 500 is that I'm referring to there. The 300 is that there. There you see my triangle, right? Okay. So that's a triangle, and I have that all the way around, because this is the triangle that I've just drawn to you on the other side. That's a triangle I've just drawn to you on the Excel spreadsheet. So I now need to determine what that is all the way around. And how do I do that? It's by working my third off there.
Yes.
So when I look at my dimensions there, it is, as you guys would have done in structures, it will be B over 3. So it's my base over 3, that is divided that 3, it will give me 100. So, and I will have my 480 divided by 2 gives me 240. And my 300 over 3 is 100, so that gives me, so it will be from there, from the center here to there is 240. plus 100 as we're going a third off my base. So that gives me a diameter of 340 millimeters. So when I now go in and I need to determine the volume of the section that I have to then do in there, it will then be needing to get to the circumference of that. It will be with my formula circumference, it's 2 pi r, and that will then give me 2 pi r will give me a circumference of, if I need to write that. No, maybe I should go to back to the other side. But bear in mind that that we're working from the center here to a third of this base here, which gives me the 340 mils. So when I go back out, you now understand why I say I would prefer to have you in my class and not sitting elsewhere remotely. That is not show yet, right?
Not showing yet, sir.
Okay, we'll go through there. Now my Excel spreadsheet shows.
Showing, sir.
Okay, so I have my 300, which is there. Okay, but I need to be over here, which is a third of my base, and that's my base. So it will be 300 divided by 3. That gives me 100 millimeters, right? Also have my 480, which is my diameter. I need to arrive at the
Center.
The radius gives me 240 millimeters. And if I add those two,
240.
it will then be 100 plus 240 gives me
340.
my radius of 340 millimeter. Now that radius of 340 millimeter that I'm referring to would be there all the way around my partial frustum of a cone. So if I insert, and I'll just try and put this over here. Insert my shapes.
I don't know if I can cycle within a circle. Circle within a circle. And then another one.
Okay. And that's not circular. Oh, no. Okay, and if I insert
another one,
another shape,
change color. Centralize. Change color. Yep.
Right. Now, if you look at, now this would be a top view of this pile, with that blue section being the under-ream section.
Yep.
Okay, so we have now determined that we now need to ascertain the line that we've now calculated for where my center would be.
From
where the circumference would be.
Oh, the printed
how do I do to make that clear? but that will now leave out my other one. But I have the smaller one in the center, which is my pile, and this would be the circumference that I would have to now work with. And as you can see there, the different colors there, when I have that, you can see. Now, the green color that you see over there, that is where I now need to determine, the circumference of the ream section in order for me to calculate what the volume would be. So what I then go in there and say, I need to now get there, and that would be 2 times pi, I'm just going to write this here, times my radius. Pi times my radius. That would be the formula that I would have there, 2 times pi times my radius. And when I do that, my radius I've ascertained is 340. I've got pi, and if you calculate that, it then should give me a length of 2.14 meters. If I've calculated that, just do it on your calculator. That will then therefore be 2 times pi times 0.34.
It's correct,
meters.
sir. Correct.
So that is 2.14. The radius of that green section would then be, the circumference of that green section would then be 2.14. And I would then have, this is where my formula comes in, 0.3, which I have is this section from there to there, times 0.5, which is height. That vertical height there, times 2.14. And because that is triangular, I need to say times half, times 16. So that is how I determine how that is. I still don't know how some of you can say that this section, that working it this way is easier, but be that as it may, that is fine. Happy to do it this way, but just remember that we need to go through all of these steps here to show and to arrive at that 2.14 that we see in there. And I trust that we are making notes on how it is that we have arrived at those dimensions. Each one of these, that one we've calculated over there, that one it's a given, the height, and that one calculated using all of these, the formulas there. Right. Other questions? I will pause. I need to know whether there are questions.
Sir, can you please just explain again the areas around the circle? What's the green for and what's the blue for?
Okay, the blue, Nomta, is the ream section, the wider section of 1080. Right? And to go there, the yellow that you see is the power. Okay, the yellow is the power. You with me? Okay.
Yes, sir.
And the green is finding the center line of this. You remember, and I will say, go back to structures. You remember that in order for you to determine with cross-sectional properties, to determine the center line or the center of gravity for a triangular shape, you needed to work off the base. You will work a third off the base, the height, a third off the base. Can you remember that?
Yes, sir.
So, and that third off the base is what I've done here. I said 300, which is that base, divided by 3 or multiplied by a third, it gives me 100. So we're sitting in there, over there, 100, over there, that's where my center line would be. And then I then need to determine what the radius is from the center here to that green on the outside. And that was 480. So I said 240 240 240, which is for the yellow, plus the 100 that I've added, that gives me the 340. So each one of these have got a meaning in how we arrive. I was hoping that I could get 3 colors to reflect in there, but obviously I'm not smart enough to be able to do that, to show. But that would be the green. There is the center of that triangular shape at the bottom there, Nonda. Does that make sense? Does that help you?
Yes, sir. Thank you.
Okay. Any other questions, guys? Remember, I cannot see if there's a hand. I just I can only go by if someone advises me that someone has a hand up.
So you said we can use a prismodial formula for this.
Yes, you can also use a prismoidal formula, but when you're using the prismoidal formula, then this would not be 6 meters, it would be 5.5 meters.
Yes. That's
Are you with me?
Yeah.
That would then be 5.5 because we would then go with a different shape there.
Yeah.
Okay. Do you mind maybe explaining it in prismoidal formula format?
Why?
Again?
Yeah.
Yes.
Okay. You understand the concept around if that is 5.5. If I'm going to put this here, that would then be 0.24, 0.24, 5.50. And that would be multiplied by what that?
Perpendicular height over 6.
That would then be
area plus small area plus 4 times middle area.
Multiplied by pi. What am I doing?
That's only formula for linear.
That would then be that there, and if we underline that one over there. Right. So now I would have measured that to the top of the underream section. So then I would then go in whereby I would then say, sorry guys, can I just pause here quickly? I will be back in a second.
Okay.